Okay, sir.
We took a mock test of reproduction in animals.
Okay, we can include 2 or 3 chapters. Okay. You guys are comfortable with 2 chapters or 1 chapter at a single time? Tell me.
Sir, 2 is fine.
2 is fine? Okay, good. So everyone noted down that in the upcoming next class is fine now, like, or do you guys need more time?
Wednesday.
Yeah. There will be a small mock test, okay, no? So in the upcoming next class, we can schedule. If anyone has any questions, you can let me know. Or if you want it to happen later on, so we can postpone it.
There will be 2 tests for me then on Wednesday.
Okay, that is
Sir,
the
can
case.
we have it on Sunday?
On Sunday. Okay. Do we have a class schedule on Sunday?
Yes, sir.
We
Yes,
have
sir.
no. Okay, so we can have it on Sunday. Everyone note it down from the chapter reproduction in animals and from the chapter light. There will be a test. Or I think, see, the reproduction in animals and age of adolescence, they are kind of related with one another. Yeah. So I think we should first be doing those 2 chapters, reproduction in animals and the age of adolescence. Okay, no? Otherwise, like, the chapters might get missed in between. So reproduction in animals and age of adolescence.
Yes, sir.
Okay. All right, let's start the revision of this. So in the last class, we had been learning about some of the chemical effects of electric current, and then there are various applications of this chemical effect of electric current. Just 1 minute. Of this. 1 minute here. Like, for example, we can extract the metal from the ores using electrolysis. Okay, now purification of metal will be done, production of compounds or breakdown of the compounds. Decomposition here means basically breakdown of a given compound can also be done via this chemical effect of electric current. So there are lots of application of this. There is one more which is not included in this, that is the process of electroplating also. Okay, process of electroplating. Out of all, electroplating is very important, so we are going to first learn about the electroplating. In the previous classes, we had already learned about, like, what is electrolysis. It's the phenomenon in which the components of a conducting substance gets split up into ions, respectively cations and anions, when electricity will be passing through it. Okay, that is one thing. Further, depending upon the nature of the solution, like which electrolyte you have taken or what is the electrodes you have taken, so several changes can be observed. Okay, now, like, as you guys know, in the beginning we discussed that in a chemical effect of electric current, either you can observe that there will be deposition of metal from one rod to another, or there will be formation of bubbles near the electrodes, or there can be color change also occurring. But all these changes depends upon the type of the electrolyte and the type of rod you are having, right? So we had this example of the release of gas bubbles on the electrodes, right? So when we take the electrolyte as water, okay, now, like, we have taken an acid water, some acids have been added into this. Okay, so when the electric current will be made to pass through this water, so you observe that on the positive electrode, what is the positive electrode, guys? Is it the anode or cathode? Positive electrode is called as anyone? Anode, exactly. So at the anode, which is positive, oxygen bubbles would be accumulated near this. Okay, now oxygen bubbles will be getting accumulated near the positive electrode, and the hydrogen gas bubbles would be accumulated near the cathode, which is negative. And why it is happening? Because when the water breaks down, it breaks up into positive ions and negative ions. Getting it? No? So hydrogen is a positive, so thereby it will be getting attracted towards the cathode, which is negative, and oxygen, which is negative ion, it will be getting attracted towards the anode, which is positive, right? So this is one such effect of the chemical. This is one such observation which we can make here. Apart from that, there will be deposition of metals on electrodes, and change of color of the solution can also occur depending upon the type of electrode you have. Right? So all of this depends upon the nature of solution and the electrode which you have. Then we did revise about electrodes. So electrodes are basically the metallic rod or conductor through which electricity will be entering and leaving this electrolyte. From one of the rod, it will be entering, and from the other rod, it will be exiting, right? And how the electricity will be flowing through this given electrolyte? So it will flow by the help of the ions, right now. So ions are basically the charge atoms, charge particles that are produced when the atoms would be either losing the electrons or will either be gaining the electrons. So when it gains the electron, it becomes an ion. And when it loses the electron, it becomes cation. That is the case. And these ions are important for the conduction of electricity. So only an impure water or only an impure substance will allow for the formation of ions in it. That's why distilled water will not conduct the electricity through it, because it does not have any impurity, hence it does not allows for the formation of ions in it. Hope that much should be clear. Okay. First, we are going to learn about electroplating. Okay, so electroplating is an example of a chemical effect of electric current only, right? And it is very useful process as it is widely used for coating many objects and parts of the objects with a thin layer of different metals. But what is the reason behind this? You all would be familiar that iron is very reactive with damp air, right now? So in order to protect the rusting of the iron, a layer of zinc is coated above it, getting it. So that is called as, what do we call that?
Electroplating.
Electroplating, particularly when it is done in the case of iron, when a layer of zinc is coated above the iron, that is called as exactly galvanization. Okay, no, you can just wait for 1 minute. I just need to take some water. I'll be back in just 1 minute. Meanwhile, you guys read this. So I'm back. Okay. So what am I saying that? Why a metal will be electroplated? So the first reason is that in order to prevent the metal from corrosion, okay, na? To prevent it from corrosion, as in the case of iron, so a layer of zinc is deposited, and that process is called as galvanization. Okay. So we see that it is very useful process and widely used in industries, right? So it is a technique of basically depositing a thin layer of metal with desired properties over another metal, right? For example, we have again, like we have this iron, and we are depositing a thin layer of zinc over it. Why we are depositing a layer of zinc above iron and not some other metal? Because zinc is less reactive in comparison to iron. Iron will readily react with the air, with the moisture, but zinc does not react with the air as fast as the iron will be reacting. Hence, zinc has the desired property. So thereby the zinc will be used here. Getting it? Further, you have some other examples, like take a look at this. Getting it? So we are doing a layer coating of chromium over this right now. Getting it? So chromium, which is a very shiny object. Okay. So some of the cost, like for example, cost efficient, for example, to increase the for in the case of cost efficiency also, right? So we know that chromium is a costly metal. So objects are made up of cheaper metal, and a chromium coating is basically applied over it to get a shiny appearance. The whole thing will not be made up of chromium since it's a costly metal. So the object will be made up of copper or some other metal. Just a thin coating of chromium will be applied to get a shiny appearance, as in the case of this door handles of the car. Getting it, everyone? So there it will be used, right? Further, just we have learned like to prevent the metal from corrosion. Okay, so that is the reason for doing electroplating. Okay, now let us learn that how basically this electroplating is being done. In order to understand that, we'll be referring to this example of uh, deposition of copper over the brass. Okay, no, and that's the animation which you can see here. Let us first learn that what are the things we need to take care of while we'll be doing electroplating. Okay, no, the very first thing is that you need to, what do we need? We need to have a setup like this. We need the electrodes, we need the electrolyte, connecting wires and battery and all that is required. Getting it? So the very first thing which we are going to do, right electrolytes and the right type of electrodes must be chosen. If you have to do the deposition of copper over the brass, so one of the electrode has to be made up of copper, another one has to be the brass. You can't choose iron or silver electrodes here. Getting it, Khadija, Roni, and everyone? Right. Further, the electrolyte that you are going to choose over here, the electrolyte which we are going to choose here, we must ensure that this electrolyte is basically the metal salt of the metal which we are supposed to like take example, like for example, no, we are supposed to be doing the coating of copper over the brass, right? So the electrolyte must have copper in it, must have the copper in it. Getting it? So thereby we have chosen a copper sulfate solution here. We have chosen a copper sulfate solution here, right? So the metal that has to be electroplated, the salt of that metal should be used here. So copper sulfate is the salt of copper here. Copper sulfate is a salt of copper here. Getting it, everyone? So in order to conduct electroplating here, to do electroplating, first thing is that you need to choose the right electrodes and right type of electrolyte must be chosen so that the metal can be deposited over this another metal. So say if you have to deposit copper on a material, we need an electrolyte that contains copper in it, right? Or say, for example, if you need gold on a material, if you need to apply a layer of gold over another material here, so you need to take an electrolyte that contains gold in it. Or say you have to apply a coating of silver on another material, so you need to take an electrolyte that contains silver in it. Getting it, everyone, what I'm trying to say? That is one thing. Another thing is that the electrodes that we are going to use, we must ensure that they are properly cleaned. They are not rusted, or there isn't any deposition of any other material over them. So that must be clean. And how we can clean them? We can clean them with a sandpaper. Okay, Alif? That is one thing. Then the electrodes that we are using here, like one of the electrode is of the same metal of which the electrolytic solution is. What is the electrolytic solution here? It is copper sulfate. Getting it? So one of the electrode must be of the same metal that is present in this electrolyte. So thereby, one of the electrode is chosen as the copper. Is chosen as copper. Getting it? Then the second electrode needs to be the material on which we want to coat another material. So in this case, this is the brass electrode. Getting it, everyone? Hope that much should be clear so far, right? Another thing is that how do we decide that this one is going to be anode and this one is going to be cathode? Yes, Khadija, how do we decide that this copper electrode will become anode? By connecting it to the positive terminal of the battery, now it will become anode. Getting it? So the metal that you are going to use for electroplating has to be made anode by connecting it to the positive terminal of the battery, and the material on which deposition has to be done will be made cathode by connecting it to the negative terminal of the battery. You guys tell me if this much is clear so far or not.
Clear, sir.
If this much is clear, then I'm going to further explain. Aleph, you getting it? Abdullah, you getting it?
Yes, sir.
Good. Now, as soon as the electricity will flow in this, what will happen to the electrolyte? You guys take a look at this animation and tell me what is happening to the given electrolyte. Keep this in mind that electrolyte here is the copper sulfate, and the formula for this is CuSO4. What do you guys think? Is it splitting? Copper and sulfate, is it splitting apart?
Yes, sir.
Right? Okay. And copper, always keep this in mind, the first element of the given compound is always the positive ion. Getting it now? So the positive ion is, what do we call the positive ions? Yes,
Cations and cation.
exactly. So these are the cations over here. Copper is the cation. Also, this here is the cathode, which is negative. This here is the anode, which is positive. Now copper here is positive, okay, and sulfate here is negative. Now it is obvious that the cations which are positive will get attracted towards the cathode now, since opposite charges attracts each other, right? So what is happening here? When the electricity flows into this will start to split. The components of the electrolyte, namely copper and sulfate, is splits. Then some of the copper will be breaking apart from this anode also. Some of the copper will be breaking apart from this anode also, right? So then you see that the copper being cations will be attracted towards the cathode. So hence this will slowly develop a layer of copper over it. It will develop a layer of copper over it. You guys take a look at one more animation here. Just 1 minute. Okay, that's a different one. I have the only this one is there. So tell me if this much is clear to everyone or not, because I will be asking questions from it. If you want me to repeat, I can repeat it.
So can you repeat the first part again?
Yeah, sure. See, the very first thing is that before we even start the process of electroplating here, the first thing that we need to ensure is that we have chosen the right type of electrolyte. So step number 1, let us consider that these are the different steps which we have to take care. Step number 1 is that we choose the right electrodes and the right type of electrolyte here. That's the first thing. Step number 2 is that, say that by the way, this point is clear now. Like you have to do the deposition of copper over the brass. So one of the electrode has to be made up of
Yes,
copper,
sir.
another one has to be brass, obviously. Another thing is that you need to clean the electrodes. If it is unclean, make sure you clean it. So clean the electrodes. Clean the electrodes. Step number 3 is that, say for example, we have to do the deposition of copper over another material. So the electrolyte must have copper in it. Getting it now? Like for instance, if we have to do
So
coating,
doesn't it count for the first step as well, choosing the right electrolyte?
exactly. That is what I'm explaining here in this one. Okay, no? So if we have to do coating of copper over a material, so electrolyte must have copper in it. Electrolyte must have copper in it. That is one thing. Now the process is such that when the electricity will start to flow through it, so thereby when electricity starts to flow, So thereby the electrolyte splits. Electrolytes splits into cations and the anions. In the case of copper, copper sulfate, that is CuSO4. Which one is the cation, guys? Copper or sulfate? Which one is cation?
Copper.
Exactly. Good. So copper is the cation, Cu2 plus, and anion is the sulfate. Now copper, that is the cation, being positive, it will deposit at which rod? Obviously at the cathode, no? Getting it? So it deposits at cathode. Then anode will be depositing at, anion will be depositing at anode. That is one thing. By the way, in the steps, in the, like, how do we choose the right electrodes? In that, I will elaborate further. Like, basically, suppose the metal that has, like, the metal that will be used for electroplating. In this case, copper is being used for electroplating, right? So that will always be made the anode. And the material over which deposition of metal will be done, that will be made cathode, right? So material used for electroplating, that is always made the anode, and the material over which deposition has to be done, that is made the cathode. So material on which deposition is done, so that is always made the cathode. And how do we decide it? Basically by connecting it to the positive and the negative terminals of the battery. Hope it should be clear. Any questions?
No, sir.
No, sir.
Okay, good. Talking about what are some of the applications, right? So it has got various applications. The very first thing is that, take a look at the given images. We see that certain type of kitchen equipments, various kind of kitchen equipments, the bathroom
So,
taps, yes,
the material which is used for deposition of the metal is cathode, right?
the material that is used for, like here the copper, the deposition of copper has to be done on this brass. Getting it?
Yes, sir.
So that's the material we are using for electroplating. So that will be made anode. Okay. And the material over which coating has to be done, that is made as cathode. That's clear?
Yes.
Hmm.
Yes.
Yeah. So you must have seen like how the bathroom taps would be very shiny, will be have a shiny appearance, right? The parts of the car, like this door handle, is very shiny, right now. So they are basically covered with a chromium coating on it, right? Although we see that chromium is a very expensive metal, but so the whole material will not be made up of chromium because it is expensive. So just a thin layer of chromium coating will be done. We'll be using any cheap metal, right? And a thin coating of this will be done over it. Okay, no? So chromium coating on kitchen parts, or like we can say kitchen equipments, door handles, like that of car, etc. Right? That is the case. So it is basically to give a shiny appearance. Next, we see that the medical equipments, like lots of medical equipment, is made up of nickel, but nickel is harmful to the body. So the contact of the nickel should be avoided. The thing is that the contact of nickel to the body can be harmful for a long period of time. But although we see that lots of medical equipments are made up of nickel, the thing is that, like, why nickel is harmful? Because it can cause skin rashes can occur. Okay, it can cause some allergic reactions also to the body. Some person can suffer from asthma also, or can have respiratory tract cancer also because of the nickel. Anyways, so the thing is that since medical equipments are made up of nickel, so in order to avoid the direct contact of nickel with the body, So coating of platinum or coating of gold will be applied on the surface of that nickel. Getting it, everyone?
Then why make it with nickel if it's harmful?
There are certain reasons why it is made, like because of its longevity and anti-corrosion properties. Okay, no, like that. Getting it now. So there are certain reasons why nickel would be preferred for making medical equipments. Okay, getting it. Although we see that a coating of platinum or gold will be done over it. Okay, now. So one such reason is that like the nickel is durable. Okay, now it is durable, and as I said that it does not corrode easily. Another
Yes.
thing is that, say for example, if I were to make medical equipments of iron or steel, will that be a good idea? If no,
So
if no, then why? Or why don't I use iron? Or why don't I use cobalt? Iron, cobalt.
What, sir? Can you repeat?
I'm saying that why the medical equipments are not made up of iron, cobalt, nickel, and steel.
iron may rust.
Repeat again.
Iron may rust over a period of time.
Okay, that is one such reason. Apart from that, okay, Abdullah, you're saying
Nothing,
something.
sir. I was just thinking what.
Okay, Khadija, what do you think? Roni? See, the reason is that now these are magnetic materials. No? Getting it? These are magnetic materials. So suppose, for example, if a person has to, like, also for example, if the implants are to be done in the body, like for example, if there are some dental implants, okay, or like for example, if there's a bone fracture, and like when the bones are severely fractured, so screws would be used to connect the bones, right? Metallic screws would be used. So that will not be made of iron, cobalt, nickel, or steel. Because if that person were to go under a MRI scanner, that can be a very deadly situation. Getting it? So nickel would be used as it is non-magnetic, right? No, so it is non-magnetic and it will be not interfering in the diagnostic tests. Okay. So hope that much should be clear. So medical equipments are made of nickel. Why we have learned, right? But its contact with the body is harmful, so thereby coating of platinum or gold is done over it. Okay, gold is done over it. Okay, next, certain kind of jewelries, like almost all the jewelries, right? So jewelry makers, we see that often would be making ornaments of less expensive metal, but they will be providing a coating of gold or silver upon them. Getting it? And you know that you cannot have a jewelry 100% made up of gold. Getting it? You cannot have a jewelry that is 100% pure gold, because pure gold, it is very soft and it is very malleable. Getting it? What I'm trying to say, everyone? Khadija, Gauri, and everyone. So the jewelry that you purchase from the market, it is not 100% pure gold, because if a jewelry were to be made of 100% pure gold, so it will be very soft and will be very malleable. Getting it? No? So that is the key. So thereby, the jewelry in the jewelry making also electroplating is done, right? So what they basically do, they will be taking a cheap metal, and over the cheap metal, they will be
Doing
doing
gold plating.
gold. Yeah, we can call that as gold plating. So electroplating of gold, electroplating of silver will be done. Okay, no, that is the
That's
case.
why it shines.
No, see, gold has the shiny appearance. Okay, no? In order to make it as strong, the electroplating will be done. That is one major reason. Okay, no? Like as I said, if I were to make the jewelry out of gold, like 100% pure gold, so 100% pure gold is very soft now. It is very soft and it is very malleable. So that is the reason it will not be used. So it always has to be electroplated. The jewelry always has to be electroplated with a layer of gold above it. That is one thing. Then the tin cans that are used for the storage of the food, right now. So there is a coating of tin on them. Basically, what we see that, like for example, if you were to make a can of iron, so it can spoil the food as it will be reacting with the food, and the food can become toxic, right now. So basically, we take iron and a coating of tin is done above the iron, as tin does not react with the food easily, hence it will prevent the spoilage of food. Getting it, everyone? So tin cans, in the making of the tin cans, coating of tin is done above iron. Hope that much should be clear to everyone. Okay. Any questions?
So can gold also be found in its raw form, like ore?
For how long I was inaudible?
No, sir, you was audible. Yeah. Now you were talking to
Okay.
us.
Yeah. So, actually, my mic got automatically turned off. I don't know why. See, what I'm trying to say that, as Chakrika has posed this question, that can gold be found in its raw form, like in the form of the ore? So yes, it is found in the rocks. You might see that it will be found in the pieces of rocks. Okay, it can also be found in the alluvial deposits. There it can be found. It can be found in the river beds. Okay, so there it is found in its raw form. So it will have some impurities in it also. So further, it is cleaned, processing is done. Getting it? No? So that is the case. Okay. Next, talking about some of the other applications of chemical effects. So there is the extraction of metal. So electrolysis will also be done to extract metals from their ores. So we have this example of the aluminum. So what is done first of all? First of all, the ore of aluminum is done. What do we do? Ore of aluminum is done. And ore of aluminum is called as bauxite. Ore of aluminum is called bauxite. Okay, which is basically aluminum oxide, Al2O3. Bauxite, not D. Okay. So what is done? This ore will be first melted. It will be first purified, like some of the unwanted materials will be removed from this. Then it will be melted and it will be dissolved in a liquid form to allow electricity to pass through it. Also take a look at this structure first. So we have taken this steel tank. Okay, now we have taken this steel tank, and to this steel tank we have connected this to the negative terminal of the power source. Okay, not like a battery, for example. So this steel tank is behaving as a cathode here. Getting it, everyone? Then we are making the electrolyte of this bauxite. So we will take the bauxite, then we will be dissolving it. So basically, the ore of aluminum, in this case the bauxite, is melted. It is melted plus liquid is dissolved in it. So now it has become an electrolyte. So we have got the electrolyte. Okay. Further, you are seeing that the anode is also taken here. Okay, now the anode will also be taken here. So as soon as the electric current will be passed through this, so this molten electrolyte will break up. It will break up it will break up into aluminum and oxides. It will be breaking up into aluminum and oxygen basically. So this bauxite here, bauxite, that is aluminum oxide basically, breaks up into aluminum and oxygen. Breaks up into aluminum and oxygen. And the aluminum being positive here, being positive, get attracted towards the steel tank. It will be settling down, while oxygen will be depositing at the anode. Let me write it over here as well. See, the oxygen will be getting, it is not visible. Oxygen will be accumulated near the anode. Why is it so? Because oxygen, as we know, will be the anion. It will be the it will be the anion, obviously. Getting it? While the aluminum is the cation, so hence it attracts towards the steel tank. Let you guys tell me if this much is clear so far or not.
So can I explain it again?
Sure. See, aluminum ore, the name is bauxite. The name is bauxite. What happens when electricity is passed through this? By the way, the setup is clear to everyone? The setup is clear? The construction of this? We have taken electrodes like which is made as anode. The steel tank is behaving as the cathode here. Okay. Then we are taking the aluminum ore, that is basically bauxite. It is broken and melted to get a liquid, or to convert it into a liquid. To convert in liquid state. Okay. So let's count this as step number 1. In the second step, what is done? Electric current is being passed through this molten electrolyte, and thereby what will happen? This aluminum ore, that is Al2O3, will break up into aluminum, okay, which is basically the cation here, and into oxygen. That will be the anion. Now remember, the steel tank is made as the cathode, right? So cations are positively charged here, right? So this will be attracted towards the steel tank or not? Will it not be settling down at the bottom? You guys tell me.
Yes, sir, it will be.
Right? Because cations always attracted towards the cathode. So it will be attracted towards the cathode. By the way, there will be a small outlet also here. Like there will be a small outlet from where it will be extracted. It will be taken away from that small hole. And the anion will be deposited near to the anode. So that is how this extraction of metal like aluminum is done from this ore. Although I don't think the complete thing will be asked in the exam to explain the working, but just so you guys know like how it basically works, it is important. Basically, we'll be getting a question about extraction of metal. Like the question would be like, what are the applications of chemicals of effects of electric current? So you just have to write in that as the answer that extraction of metal is also done using the chemical effect of electric current. Nonetheless, you have learned how it is done. Any questions?
No, sir.
Okay, good. Another application is that in the purification of metals also electrolysis is used. Okay. So let us understand that how it is basically performed. Okay. So suppose you have to purify this impure rod of copper. Okay, now you have to do the purification of this impure copper rod. It has got lots of impurities in it. Suppose some mud particles are there and some other unwanted materials are there in this copper rod, right? So with the help of electrolysis, we can purify this. Okay, now we can purify this. We'll be getting back to that in a while, but you guys take a look at this animation first and look at what is happening in this. This is the impure copper rod, and the impurities from the copper rod what is happening? It is dissolving into the electrolyte and it settles down at the bottom of the anode and is being called as anode mud. Also, the copper from this anode is breaking up. It breaks up and further is getting deposited at the cathode. So you notice how due to the deposition of copper over the cathode, it is becoming thicker. It is becoming thicker. So basically this process involves purification of the copper rod here by removing the impurities from it. Getting it? So let us understand some of the important things here. The impure metal is used as an anode here. Always keep this in mind that the impure metal will always be made an anode by connecting it to the positive terminal, as you can see in this case. Okay. Then obviously the other one will be made a cathode. So the metal over which deposition of the copper will be done, we'll be basically taking a thin plate of copper. Like you can take a look at this one here. You have taken thin plate of pure copper over which all the copper would be deposited from the other rod here. Getting it? So the impure metal is used as an anode which first dissolves in the electrolyte and then deposits on the cathode in the pure form, and then deposits on the cathode in the pure form. And the impurities of the metal remains in the electrolytic solution and it will deposit at the bottom of the anode. It will be depositing at the bottom of the anode, and that we will be calling as anode mud. That will be calling as anode mud, right? So different kind of metals other than copper is also purified using this method. You have aluminum, you have got zinc, they are also purified in the same manner. Tell me if this much is clear to everyone so far.
Yes, sir.
Okay, Roni, you tell me which rod is used as anode here, the impure or the copper rod? Sorry, impure or the pure rod is used as anode? Khadija, you will tell me where does the impurity settles? It settles beneath the anode or does it settle beneath the cathode?
So can you repeat?
The first question is, in the process of purification of a given metal, which metal is made the which one is made the anode, the pure rod or the impure rod? You guys can take a look at the animation and answer from that as well. Repeat again.
The impure rod.
Impure rod, exactly, no? So impure rod is made as anode. And where does the impurity settle down? Beneath the anode or beneath the cathode? Alif? Gauri? Yes, Khadija?
Beneath the anode.
Beneath the anode, no? Abdullah, you read the given paragraph quickly.
Yes, sir. Purification of metals. The method of electrolysis is also used to purify a metal by separating it from the impurities. The impure metal is used as an anode, which first dissolves into an electrolyte solution and then deposits on the cathode in the pure form. The impurities of the metal remain in the electrolyte solution. Only metals like aluminum, zinc, and copper are purified in this way. Yes.
Okay. So basically, we are seeing that. You guys take a look at this animation again. I think many of you are not still getting it. Khadija, what about you? You getting it? Roni is silent, not responding. Once again, take a look at this animation. What is happening here? The copper from the impure rod is dissolving into the electrolyte. So thereby, slowly it is becoming thinner and thinner. And all the copper, since coppers are cations, they are positive ions, so they will be getting attracted towards the cathode, which is negative. And the cathode, notice how it becomes thicker and thicker. And the impurities, many times it remains in the suspended in the electrolyte, many times it will be settling down beneath the anode and will be called as anode mud. So that sorry, that is how it is done. Another is the decomposition of compounds. Decomposition basically means a breakdown of a compound. So a given compound can be decomposed into its constituents. Like, what is the constituent of water? Water is made up of hydrogen and oxygen, isn't it? All of you turn your cameras on in the class. Yes, Chakrika, Abdullah, Alif, Gauri is here or not? Yes, Gauri. All of you turn your cameras on in the class. Many times I have got to know that many times, like, students would be just laying down in the bed and would be just walking here and there and would be attending the class in this manner. So that is not the way to attend the class. No, everyone should make sure to sit in a proper place and turn your cameras on and show active participation in the class. Good. All of you. Yes, Khadisha and Roni, you guys also. So decomposition of compound basically refers to breakdown of a compound. You can break a compound into its component. Like, I can break the water into hydrogen and oxygen and I can use it as fuel. So what is happening here? I cannot use a impure water now. There must be something added to the water. Like, I have taken an acidic water. I can add sulfuric acid in it, or some other acid can be added in this. Okay. So I have taken this beaker. By the way, you guys just take a look at this video once again, and that will give you a proper explanation, and as well as you will get to know how you can yourself make it under under proper guidance. So right now distilled water has been taken, but this person will be adding some acid into it. So a battery has been taken, and see how the electrodes were taken from the electrical cells, and he is putting it into these test tubes. Okay. And from this battery usually contains sulfuric acid in it, so he has dropped puts few drops of sulfuric acid in that water to make it an electrolyte. And notice bubbles are accumulating here. Getting it? The bubbles are forming here. And notice when he will be bringing a matchstick near to this, so hydrogen gas will burn, and hydrogen gas always burns with a pop sound, while oxygen burning, during the burning, oxygen will not give any sound, but whenever hydrogen gas burns now, it produces a pop sound. Getting it? So let me explain once again. So what has happened here? The water has broken down due to the passage of electricity through it into H plus ions, okay, and O minus ions. Getting it? And cat ions will be getting attracted towards the cathode. Getting it now? So in this case, hydrogen is getting attracted towards this cathode here. So one of the rod has been made cathode. Take a look at how it is connected to the negative terminal of the battery to make it cathode. So hydrogen gas bubbles would be accumulated in this test tube that contains the cathode, while oxygen, being anions, will be attracted towards the anode, the test tube in which anode is present. So we have split up this compound in this manner. Hope it should be clear to everyone. That was decomposition. Okay. Further, we see that certain kind of compounds can also be created using this method. Okay, so let us understand this. Okay, so we have this chlor-alkali process, although you won't be usually asked about this in detail, but I thought you should know like how it basically occurs. Okay, so there is this process of electrolysis in which we can obtain products like sodium hydroxide, chlorine gas, and hydrogen gas can be obtained. Sodium hydroxide is a base, or is it an acid? What do you guys think?
Pardon, sir?
Base.
It's a base. Sodium hydroxide, the question was sodium hydroxide is a base or an acid. So it's a basic substance, no? Okay, let us understand like how with the help of electrolysis, certain compounds like sodium hydroxide and some other things can be produced. So first of all, we have taken a solution of salt in the water. Sodium chloride solution has been taken. Getting it, everyone? So you have taken an electrolyte which basically contains common salt, that is sodium chloride in it. Sodium chloride. So we have taken the electrolyte. Okay. Next, electricity is being made to pass through this. By the way, the solution of salt in water is also called as brine. Okay. Also called as brine. Anyways, when the current will be passed through this, so thereby this sodium chloride will break up. So that is NaCl will break up as Na plus and as Cl minus ions. Getting it now? So what happens? The chlorine gas will be getting accumulated near to the anode, since chlorine is negative. Getting it? While we observe that water is also like hydrogen is also present in the electrolyte now. So hydrogen will be getting accumulated towards the cathode. So bubbles are these bubbles you can observe here. How do the hydrogen gas bubbles and chlorine gas bubbles are being formed? Then formation of sodium oxide is also going to occur. So the leftover sodium ions and the hydroxide ions in this will combine together to form sodium hydroxide. So that will be NaOH. Getting it? And later on, the sodium hydroxide can be used in the manufacturing of soaps and detergents, and the chlorine gas obtained will be used as disinfectants. Right? You guys know, like in the wastewater treatment plant, chlorine gas is used to get rid of the harmful chemicals from the sewage, right? And hydrogen gas will be used as a fuel. So how would we identify that in which test tube there is hydrogen and which one is oxygen? Okay, see, in order to identify this, now see, both of them have got different properties. Suppose if you were to bring a matchstick near to this now, so the hydrogen gas will burn and it will produce a pop sound. So that is the characteristics of the hydrogen gas. Getting it now? And chlorine gas also have got a distinct smell. Getting it? So it has a smell similar to that of a bleach. So it has a very strong smell. Getting it now? So it has a very strong smell, like a very pungent smell, and that will cause some irritation in the nose. So that's the characteristics of the chlorine gas. So if someone were to smell it, so that will cause some irritation in the nose. So nonetheless, the important thing you need to get from this is that we can produce some compounds like sodium hydroxide using the electrolysis method. Okay, so that was all there in the chapter. In the next class, we'll be doing some questions. Okay, now we have got few questions that we'll be doing in the next class. Okay, that's
Okay,
it for
sir.
today's class then.
Bye, sir.
Yes, bye.
So